Welcome to Eason Academy. We are into embedded system programming. As a part of embedded system programming, we are into embedded programming. And this is session 4. And we are discussing about using 7-segment displays. And somebody has asked in the last session, what is the internal architecture of the 7-segment? Okay, I just explain to you now what is the internal architecture of the 7-segment display. I've explained the last session, but still I'll once again explain to you that. So that you will be able to understand it. So what is the internal architecture of 7-segment display? That's nothing. So you have a display and we have so many pins. Well, like this is common pin. This is common pin. There are 2 common pins. And we have a displays here. This is what your 7-segment. And we have 1, 2, 3, 4, 5, 6, 7, 8. That means that 8 pins are for the 8 anodes and whatever it is. The common can be like this. There are 2 methods of connecting. The one method is this. I have 8 LEDs, 7-segment. I connect all the cathodes. And the anode will be connected to the pins A, B, C, D, E, F, G, H. And this is cathode. This dot, sorry. That means that this 7-segment is called common cathode. Why they are mentioning common cathode is it is pins. This is A, B, C, D. Example I'm giving. F, common. G, dot. If you give 5 volt, the LED will glow. That means that if you put all once, then the LED will glow. That is what the meaning of common cathode. This is what internally everything is nothing but a LED. Even though you see everything like this, a bar-like thing, underneath the bar there is a LED. There is a light, and they put a bar there. That's the way they designed it. So underneath every bar there is a LED. They are called 7-segment 1 dot. 8 LEDs are there. But the LEDs can be connected other way also. LEDs can be connected other way also. That is this. I will show you both. Right now, I'll show you on the diagram. How do we do that? In this case, you have to connect it to 5 volt. This is common anode. But this one, A, if you make it 0 only, the LED will glow. If you make all of them are 0, the LED will glow. This is called common anode. So please understand there are 2 types of LEDs. One is called common anode, common cathode. If all the LEDs, every LED is having two points, anode and cathode. If you connect all the anodes together, it's called common anode. If you connect all the cathodes together, it's called common cathode. Okay, now let us go back to the board. I'll show you now as a common anode how it works. How it works as a common anode. Now I display here 7F. If you put FF, see that. If you put FF, I'll run it. You see what is happening. All even dot is on. If you make only 0, 1, I make just 0, 1. See that. What is on? I stop it and run it. See, only A is on. If we put 0, 2, that means that but it's still bigger. Okay. So that means that when I put 0, 2 means 0, 0, 0, 0, 1, 0. Sorry. 0, 1, 0. Am I right? This is what the meaning of that. Okay. So if I put 0, 4, this will be on. This one. So 1, 2, 4, 8, 16, 32, 64, 128. That's all. The combination, you can add anything, whatever you want. So each LED has been position wise 1 to 128. You whatever LED you want to add the numbers, you will get it. The trick here is this. This particular online package having advantage. See here, you can make them as a common anode or cathode. Now you see that common anode. I make it as a common as an anode. You can go and change in the diagram.json file. Anyway, I start this file to you. You can look into the file. Now I come back. You see here, I put 0x4. Am I right? Now I stop and run it. What is happening? Let us see. The connection does not work because I made it as a common anode. I connected the pin to the this one. What do you call? I connected the pin to the ground. So if you say common anode, then the pin has to be connected to VCC. See, now I'm connecting now. Okay, now I connected to 5 volt. Now let us see what is happening. I don't change the program now. Now you see that. What is happening? See that? Wherever the 1, that is not on. Okay, but wherever it's a 0, now let us make everything as 0. I put all of them 0 now. See that? What is happening? See? Lights are going. If you put all of them 1, FF. See, when I put FF, that means all 1. When I put all 1, then the lights are off. So this is called common anode connection. That means that in real world, you get 2 ICs. You cannot change. If you buy an IC called common anode or common cathode, that's a real word. Since it's a simulation, you can change it on here itself. I can change so many things. I can also change here color. Blue. I change the color to blue now. Now if I display here, if I write here all zeros, I run it, I get blue color. See, I got blue now. So please understand, if it is a common anode, you should connect the common pin to the VCC. If it is a common cathode, you should connect to the pin to the this one. Otherwise, your program will not work. You think that you have a problem in the program. Now you may ask a question. Why they have made this as a common outside? Why they don't connect it to ground directly? Am I right? That is a reason. That reason I'm going to explain to you now. Because I changed. You can change here. I changed the color to blue now. See here, blue. I can change it to green. See that. You can change it to green and that become green now. See here. This advantage here, you can change any color. You can change any color here. These are the advantage of simulation. But the beauty is, if you write the program here, see, I write a program here. I'm going to give a lot of exercise. If you do all the exercises, then it's good. Then the same thing is hardware. I'll show you. Then once you have done this, then I'll tell you how to connect it on hardware. Am I right? So when you cannot do this here, then you get confused in the hardware also. First, try to understand everything on this. All the things are fortunately available to you free of cost. This whole thing is available to you. And another advantage is, whenever you have a doubt, you send the link. You go to the share and take the link and send it to me. It's not working. I will change the code and tell you that what mistake you have done. That is the advantage of this mechanism. You just have to share it to me. Now I'm going to have something. Let us say I wanted to connect two displays. Now, how many connected? I want to connect two displays. You understand? I want to count from 1 to 10, two displays, not 2 digit, not 1 digit. Then what will I do here? See here. I go here. I stop. I take one more 7 segment. I've taken one more 7 segment. Am I right? I've connected this pin to the 5 volt. I have to do everything. Am I right? Common pin. Then this port I connect A. It takes so much of time for you, B. C. T. You can watch how I'm connecting. That's why I'm drawing before you, even though I know that it's I'm drawing you because I want you to understand how I'm drawing. I just connect there and do the things. Things are simple. F. G. Dot. Now I connected all. Now I connected two display. Now I have to find out what is the address of this guy. Now I want to display 25. Let us assume that I want to display 25. Now, how do I connect? How do I do here was for 2, this. Let me change it to common anode, cathode. That only you'll be able to understand. Common anode means you get confusion always. You have to make all 1 to 0. That's a problem. That's why I made this a common cathode. Common cathode means 1 means on, 0 means off. Common anode means you have other confusion. Okay, now let us display. I want to display 25 here. 25. For 25, A, B, C is not there, D, E, F is not there, G. Sorry, I have not shared the board. Okay. So for 25, A, B, C is not there, D, E, F is not there, G is there. So it means that 1, 1, 0, 1, 1, 0, 1, dot is not there. That means that 2 means 5B. Now let us talk about 5. A is there, B is not there, C is there, D is there, E is not there. A is there, B is not there, C, D is there, and E is there, F is not there, G is there, A, B, C, D, E is not there, sorry. E is not there, F is there, G is there, H is not there. That means that 6, what mistake I'm doing once again, sorry. A, B, C, D, correct, 1, 0, 1, 1. Then E is 0, F is 1, G is 1, dot is 0. That means that 6, D. Now, let me go to the program. Now we found the value. Now we go to the program. The problem here is this, if I write here 5B, I get only 2. I get only 2 here. But I want 2, 5. So what I have to do is, I have to find the port of that one. So in the display, I see that is port K. Now I have to find what is the port K address for the diagram. What is the port K address? The ports. Port A is there. Like that, what is port K? Port K is what? 108 is the data register. 107 is the direction register. So I have to go now here. I have to go to the program. And I have to say here, dir digit 2. I'll give one more thing called dir 1. Dir is equal to 0x107. Then star dir is equal to 0x ff. I make all them output. Now I say here 5b. Now I'll say out is equal to 0x108. Star out is equal to 0x 6d. Now let me run the program. See that. Oh, the address is wrong. Anything? I don't know. I have to check. One not 7, 108. It's correct only. Am I right? I don't make any change. Port K. This is port K only. That's correct. One minute, let me check what is the problem. It's connected to ground. That's correct. Oh, this place. Oh, sorry, I did a mistake. You know that. See here, the problem is here. The second display, there are two 7 segment. The second 7 segment, I did not make it as a common anode. Common. Cathode. Okay, now let us run it. That's why I thought, what is it? We have done everything proper. See here, now I got 25. Is it clear how I got 25? If it is not clear, let me know. So I have 2 ports now. I connected, first one is 30. This is actually port F. And this one is port K. And this one is once again port F. And this one is port K. How do I know that port K and port F? Because I have connected here. This is given by the Arduino people. This is port F and port K. I don't think this is the reference manual given by the company. You cannot do anything with this. And this manufacturer has given me that what is the address for port K and port F. I've taken the address. So nothing you can think. You do only one job. What you do is now I will ask you later programs like this. I want to display here from 0 to 99. Slowly display 0 to 99 in the rotation basis. I will say that. And that's the problems we are going to solve them. Correct. Yes, they will give you. You have to read the data sheet. Every company you have to read the data sheet and you have to get the address. These addresses will change on every company. You are right. That is why the interviews, the companies wanted you to know this one information. If you don't know this information, if they give you the new project, you cannot handle it. You should understand this. You should. They will test you. What is his address? How do you get the address? I mean, like, if you write this program, they'll be happy. That's a trick. If you write a program like Arduino program, set pin, digital write, and pin mode, something that unfortunately that will not be available in other companies. That's the reason they wanted you to understand as an embedded engineer. They want you to understand the pointer and the address and write it that. That way you should know. This is given by the every company. Let us do a small thing here. I will show you the same thing in the ARM chip. I'll show you the same thing in ARM chip. Even last class I showed that. If you go to the ARM chip, all these things are shared in the data sheet with you. Okay. This is all there in the thing, data sheet in the thing. I've shared that directly. Now, the ARM manual, they have it. They have a memory map. See, they have this block diagram. See here, the block diagram shows that. See here, this block diagram shows that they have how many ports. See here, port A, port B, port C. They have 16 pins, 0 to 15. Port A, port B, port C, port D, port E they have. Now, they given an address here, the bottom. They have a memory map. These are not common. What I showed you is any chip you take, they will tell you what pin it is and what is the data. See, you as a embedded engineer, you need not have to do too much, but you should understand what is what. You are not going to do board design, but you should know what, because see here, this is what the data sheet. Every port, what is address they given. See here, 4001. I hope you, this is, I'll zoom it. See here, port A, what is address? Port B, what is address? Port A starting address is 400180. Port B, everybody is having the address. If you go inside, they will tell you what is a direct register, what is out register, what is a in register. So these are all given by the data sheets of the company. Okay, I just, for sample, I've taken this. Now is a trick happen. I'll tell you the trick now. Now let's go to the board. So I have shown you now, how do I control 2 displays? Okay. Now, how do I control 4 displays? If I have to control 4 displays, think of it. If you have to control 4 displays, then it is 4 ports. Am I right? But these people did a very beautiful thing. What they have done was, let us take only 2. Let us take only 2 displays. Let's take 2 displays. Let's take two displays and let us understand that. Correct. But the engineers solved the problem nicely. That's what I'm going to explain to you now. Now we'll start with the two display. You have A. Both the displays having a B, C, D, E, F, and dot. The dot is having a, so G is a dot. Am I right? Now all these guys, cathodes, this is a diode. They connect all the cathodes. Forget about now cathode. I'm not worried about cathode now because it's a common cathode. Suppose I have a microcontroller which is having a port. The 8 pins 0 to 7. I connected 0 to A. The same A I connected here. Think of it. I connected both the A's. Same way, I connected both the B's. And I connected to pin number 1. Like that, every wire, let us say G, I connected to the 6th one and connected to the G. That means that if I give out here, this one port, if I say out, star out is equal to 0x01, the 1 will come here. Now this light also will glow. This also will glow. Both will glow. So people thought, how do I control that? For that, they have done a beautiful thing. What they did was, they have one more port. They take only 2 pins, not 8 pins. How many pins they have taken? 2 pins. This they connected to the common cathode. This they connected to the common cathode. Now, if this, let's say this is a port 1, this is out 1. This is out 2. I have 2 ports. And in the out 1, I display 1. That means that this one is on. But here, out 2, I make it everything as a 0x03. 3 means 1, 1. Now what happened? This is a common cathode 1. So cathode should be 0. Cathode should be 0 to display. But since I made it 1, the both light will not glow. If you make it 0, 1, if you make it 0, 1, what will happen? If you make it 0, 1, since this is 0, this light will glow. If you make it this 0 as 1, now this will glow, this will not glow. Do you understand what I'm doing? There's one small extra thing. Now, let us take it with a small one. Let's not take too many things. I take 2 LEDs. I take 2 LEDs. You will understand this. I connect this one to ground. I connect this one to ground. We assume that we have a resistor. Now I have a port. I have another port. This is star out 1 is equal to 0x01. So it become 1. Now I say star out 2 is equal to 0x01. This is 1. So both LED will glow. Because this is 5 volt, this is 5 volt. There are 2 ports, 2 pins. Now what I have done is, I have removed this. I've removed this. I've connected this pin to this pin. Now what will happen? Tell me. Now tell me what will happen. Will the LED will glow or not? The LED will go or not? And tell me the answer why. Now, LED will not glow because this is 5 volt. This is 5 volt. The potential difference is 0 volt. The LED to glow, the difference should be 2 volts. Now it is 0 volt. The LED will not glow. But if I make here 0, the LED will glow. Do you understand now? That is what I am doing now. I am controlling the LEDs on or off by controlling. Why it is used, I'll tell you now. I take the same pin, I connected one more LED. And I connect to another pin. See here, pin 1. Now if we put here star out, so 0x03, 3 means 1, 1. Both are 5 volt. That means that this difference is 5 volt, this LED will not glow. This difference is 5 volt, this LED will not glow. Suppose I want to make this one to glow. This one to glow. What will I do now? I'll take this out. I will make this one as 0 volt. That means that I will out to 1, 0. Now this light will glow. If you make it as a 0, 1, this is 0 volt, this is 5 volt. This will glow, this will not glow. So I have 2 LEDs now. I have 2 LEDs, but I'm controlling through only 1 pin. Forget about this pin. This is a ground pin. LED anode is controlled through only 1 pin. With that, I'll be able to control the 2 LEDs. Is it clear? If it is not clear, ask me, please. It's a very important. I have connected 2 LEDs and I am now controlling the cathode, not the anode. This is a very important display thing because when they connect 4 segment, normally we require, if you have a 4 segment, we require 4 into 8, 32 pins. But we use only 8 plus 4, 12 pins. We save 20 pins. If I have 8 segments, I need how many pins? 8 into 8, 64 pins or 8 ports. But with this method, I'm going to use only 8 plus 8, 16 pins. You have to understand this. If you don't understand, ask me once again. There's nothing wrong. That is, I'll draw it once again now. That is, I have a port. I connected 1 LED. If I output 5 volt, this LED will glow. Okay. Now I connected 2 LEDs. 2 LEDs. Of course, I'm assuming resistor. Now, if I give 5 volt, both the LEDs will go. So normally we think to control 2 LEDs, we need 2 pins. Am I right? To control the LED, I need how many pins? 2 pins. If I out is equal to 0x00, both will be off because you are giving 0 volt. If I give is equal to 0x01, then 0 volt and 5 volt, this LED will glow. If you put 0x10, this is 5 volt, this is 0 volt. This will glow. If you give 0x11, both are 5 volt, both will glow. Understand? This is the mechanism. But what engineers did was, instead of having 2 pins, they have used only 1 pin. Now what will happen? There's only 1 pin. The pin can be 5 volt or 0 volt. Now, if I give 5 volt, then both the LEDs will glow. If you give 0 voltage, both will be off. You cannot control only 1 LED. Then let us discuss how do I control both the single separately. Then I have one more port. I connect it to the cathode. If I output here 0, 0, that means both are 0. If I give 5 volt, both will be on. If you give here 0, 1, now what will happen? This is 5 volt. So 5 volt and 5 volt, this will be off. Only this will be on. If I give 1 0. This is 0 volt. This is 5 volt. This will be off. This will be on. So what I do is I control the cathode, or we can call common pins of the thing. This is the trick. This is the way. This is actually called a word we use, multiplexing. This is called multiplexing. I'm using only one output, but control 2 cathode. Now you may think that, oh, I'm wasting 2 more pins. But when I have multiple one, when I have 8 segments, then it becomes very easy. Then it becomes 8 plus 2, only 10. But otherwise you have to use 8 plus 8, 16 pins if you use 2 segments. So this has to be understood very clearly. That is, if you don't understand this, you don't understand the other one. That is, I have 2 LEDs. Both the anodes are connected. Both the anodes are connected and connected to the port. If I give 0, both will become off. If I give 5, both. But what we have done was we control the cathode through another port. This has to be understood very, these are all the direct controls. You need to understand this. But to do this programming more and more, it's very easy. But the problem here is these are all basically a skill. Still, if you understand, first you make LED connections, multiple various types of LED connections in the board. If you draw this, for example, if you draw this diagram on the board here, the problem with that is we have been always trying to listen, but that does not work on the industry. Industry want you to do. Understand now. Industry want you. That's why I want to share. That's why I want you to do this. I'll take a new board. I'll take another one. Let us see that. How do I connect? You connect that. Let's see that. Okay, the same one, but I'll make it. I'll remove these connections because otherwise I have to type the code. So, okay, now what I do that, I'll remove this. Everything is gone. Now I connected 2 LEDs. See here, I added 2 LEDs. I add 2 LEDs. See that. Now this anode is connected to the pin 0. Now this anode also connected, same pin. One pin is controlling both the LEDs. Now I add a resistor. I add another resistor for another LED. Am I right? Now this one I connected to this one. This one I connected to the no number system and all we don't teach. It's all only videos. Number system video is there on the thing. Number system we don't teach. Because it's a very simple one. A lot of people know that. We don't want to waste the time on this. Okay. Now I connect it to ground. You've seen it now. Now, see that both the anodes are connected to the single pin and both the cathodes are connected to ground. Now I'll output the pin. This is port number 30. Port number 30 is correct. Now I put output as a 1. Now I make it as a 0, 1. I make it as a 1 only. Now I run it. See that both the lights are glowing. I control only one pin. I write here 0, 0, 0, 0, 0, 0, 0, 1. But both the pins are glowing now. How do I control them? So what I do now is very clear. I off this. I'll remove the connections. But the first LED I take, I connect it to this pin of the other port. The second one, I connect to the other port. I don't connect them to this one. Now you see here, now I have another port. This direction 0x107. That's the direction. Start. See, I'm trying to see. You may be a little bit confused. I'm trying to take a different route. Why I'm taking this different route is, otherwise I can directly write port A, port D like that. No, I want to show you the actual thing with the C. This is the code is common in all the microcontroller. Otherwise, you will be writing a code depending on only. That's why most of the people ask me when they join the course, sorry, which microcontroller you will teach? I don't understand because it's a confusion. This methodology, the moment you are going to discuss about ARM, it will become very easy. And you know that 90% of the embedded system is with ARM today. You do not have to study with ARM once again. It becomes so easy. Now, what I do here is out is equal to 0x108. I make star out zero 3. I make both the pins are 1, 1. Now, even though I send this pin 1, both the LEDs, now what happened? Since both the pin 1, 1, the thing will not glow now. Nothing will glow. But instead of 3, I make 2 now. If you make 2, because I'm controlling the other port. See, now that guy is, this one is glowing now, which is connected to the bit 0, because that is 0. Now I've written 0, 0, 0, 0, 0, 0, 1, 0. Since this is 0, the first LED is going. Now I want to glow, this one to glow. I have to make like this now, 0, 1. You see that I'm going to show you one surprise one. But one thing, what I'm going to do now is see that now. Now I do this now. Now see that once again. Now watch this one. Now you see one thing very clearly. You see very clearly only one thing. If I don't do this, the bottom one, what is it? See the top one, I make one LED on. So take the bottom one out. I don't do this. That is the 4 lines, I remove it. I comment it out. Please watch this, very important. This is what the trick of the display today. You better understand now. Now I see here, I comment out the bottom 4 lines. I'm executing only the top 4 lines. Now see here, when I do the top 4, one LED is on. Am I saying? Now, when I do bottom one, when I do top one, so top 4, what is happening now? See that. only one LED is on. But when I do both run, when this is on, this should not be on. When this is on, this should not be on. But what you see here, what you see on the screen, what do you see now? I'm not giving, it is not possible in my code. Am I right? Do you understand that? Do you understand this? If you don't understand, ask me. Now you see here, if I don't execute the top 4, if we don't execute the top 4, only one LED is on. That is left. Now, if I do this one, bottom 4, remove it. The light is on. But when I remove both, when I execute both, you see both the light is on. This is called your nature. This is called the nature. Your eye is having a retentivity power. Even though the light is on now, when in this case, first case, one light is on, the second case, one light is on. The beauty is, since this guy is in a loop, the on time is less. Now I'll do one thing. Between the off, I make a delay now. See here now, I'll make a small delay. I make a small delay now. Understand now? After this, I make for I is equal to 0, I less than 50,000, I plus. I execute the, sorry, for. Now I execute the same code here. Bottom. So after every display, I'm making it off. You understand? Now let us run it. What is happening? Let's see. See that? It is blinking. If I increase the display to 1 lakh. See? But when I reduce the display to 1000, when I reduce the display to 1000, now you see that. See? You don't see the blink at all. Actually, they are blinking, but you don't see because your eye cannot distinguish such a small delay. If you on the light and off the light, the problem is with your eye. If you on the light and if you off the light in a very short duration, your eye will retain the old one. So this is no technical explanation. This is the nature given you to the eye, that facility. Now you know that in your house, if a bulb is blinking only 50 times, you don't see them. Am I right? No, it doesn't matter. It's only your eye. That is your eye. Okay, you can display different cases. I'll show you now. That is fine. That's good. That you can try. See, the thing is that whole thing I'm going to give you, this whole thing is recorded. I'm going to give you. If you go and watch the video and try the same thing on the simulation, if you don't get it, let me know. You can try everything. You are being nature by nature. You are trying to ask and get the answer. That is not the way today. In 2022, the world wanted you to do it. You should be a skilled person, not a knowledgeable person. See. Now see here, one guy blinks faster, one is slower. See that? Am I right? You can have any number. See here, I can put 2 lakhs here. I can put here 20,000. So one is not at all blinking. You don't see that light. For example, this one I reduced it to 1,000. Reduced it to 1,000. See here. See, one is keep on, one is blinking. Yeah, this is the way you have to try it out. You have to start with a single LED, and if you don't understand the concepts on the LEDs, you will never understand 7 segment. If you don't understand 7 segment, you will never understand LCD. If you don't understand LCD, you don't understand dot matrix. That's the way it goes. That is like this. If you don't understand the Elio, this whole code is with you. I'm sharing everything. And if you want, I can share this also. I'll save this one. I'll save this one as another file. I'll save a different file. Okay, I'll share this. You should get this. Yeah, the problem is you have time. See, these are the what I discussed. Even though that I supposed to complete today that switch and keypad. No, I'm not doing that. I'm going pretty slow because I want better you understand this concept. This concept, what I discussed in the last session, LED, and today's 7 segment and LED. These are very, very important. If you don't understand, if you're not good at this programming, and your foundation in embedded system programming itself is going to be shaky. Understand? This is very, very critical for our discussion, future discussions. Let me do one thing. I'll share it out. Some problem with the thing. This is almost, see, this one is too good. It's free actually. You get such a nice one, you know, online. See that I am sharing it in a minute. There is the advantage. I share this thing to you in a minute. Understand? Go and watch these videos. No, this ones. You get the, I'm not only videos, I'm sharing the same diagram. You can change and do the things. The more you practice, please understand, these are not joke. Don't think it's a very light. This is what exact. The same thing, you connect the wires, you will get the output on the actual board. One advantage here is these things work very well, pretty much very well in the simulation. So don't think that simulation is different and board is different. Both are same. If you know here in simulation, you will do wonderful on the board also, please. So understand that it's all, nothing is complicated. Color code of resistors and not a thing. I'll explain to you sometime in the later classes. Okay. This is BB Roy, Great Britain, very good voice. That's all. They have a, I'll share it on the thing. Anyway, I'll just stop the recording.